Hi, I am Aditya. This is my autonomous wall finishing planner assignment. I'll first demo the product behavior end to end, then explain the planning logic, and finally walk you through the backend architecture and separation of concern. On the left interface, it lets you configure the wall dimension, tool width, overlap ratio, sweep axis, and start corner. An obstacle is also configured here, as you can see. And let me add you one more obstacle. And the gray thing that you see in this whole dimension is the obstacle for us. So when I preview the backend returns a full trajectory and planning matrix. I also surface explanation such as total points, pain points versus move points, total estimated travel distance. This gives you a quick quality signal for each generated plan. Now let me simulate the whole running for you. And as you can see, our whole simulation ran, and this basically demonstrate the obstacle-aware planning behavior that we have done. Now moving on to the architecture, I keep the strict separation of concern. Route are thin and only handle HTTP contracts and response shapes. Schema hold validation and typed request response models. For example, C plan contract.py. As you can see here, for obstacle and wall validation, service implement planning and storage business logic. Persistence is isolated behind a SQLite layer with index tables for plan, obstacle, and trajectory points. Real-time messaging is handled by an in-memory broker, as you can see broker.py, with topic filtering and cursor-based event polling. And planning logic uses a zigzag sweeps, computes free segments by clipping obstacle influenced block regions with a clearance epsilon, and inserts non-paint transaction when movement between paint segment is needed. For block transition, it builds axis aligned waypoints and uses shortest path search to avoid obstacle interactions. And now you can also let me test it for you. PyTest q minus q, basically flag q lets you run the whole test we have in our Python app. So test planner, test real time API, test storage API, and also we can move in a vertical axis. So let me show you that as well. So preview, we have to do a preview path. So basically get the information from the backend, and also we have the real time for plan created, plan deleted, and as well. So basically when you save a plan, it lets you a real time event as plan dot created. Now playing it in the vertical axis direction. Now, as you can see my whole application is robust when it comes to obstacle detection and covering the whole dimension of our of the wall. So thank you for the review. My focus here was for correctness, safety margins around obstacles, and clean modular backend design. That is easy to extend basically. So thank you once again for the video tour.